Hi, and welcome to another video on meteorological instrumentation. In this video, we're talking about SI units. So we're going to go through the International System of Units. There are 7 SI base units that are mutually independent. And here they are. And we're not going to go into them in great detail. We just want to make sure that you're familiar with these base quantities. The 7 are length, mass, time, electric current, thermodynamic temperature, amount of a substance, and luminous intensity. And the units are, the unit of length is meter, unit of mass is kilogram, unit of time is second, the unit for electric current is ampere, the unit for thermodynamic temperature is Kelvin, the unit for the amount of substance is a mole, and the unit for luminous intensity is the candela. We're going to look at just a few very quickly. The definitions are pretty detailed. For example, the unit of length is meter, and here's its definitions. The length of the path traveled by light in a vacuum during a time interval of 299,792,458 of a second. So that's pretty detailed. Notice that the units are based on a constant, and in this case, the constant is the speed of light in a vacuum. Kilogram, the definition changed in 2018. The old definition was that it was equal to the mass of the international prototype of the kilogram. There was a block of metal, I can't remember exactly the type of metal, and it was the prototype. But it was in a vacuum, but it was gaining weight, believe it or not. It was changing. Probably because of oxidation and other things, even though the vacuum, maybe there was a slight amount of oxygen in there. So as a result, it's not a good thing for the kilogram to gain weight. It's okay for you and I to gain weight, but not the kilogram. So now they're basing the kilogram, as of 2018, on a constant, and that constant is Planck's constant. So the new definition is it's the fixed numerical value of the Planck constant when expressed in units of joules per second, which is equal to, well, of course, joule per second is a kilogram meter squared second per second, where the meter and the second are defined in the other definitions of SI units. The meter in terms of the speed of light, and also the second we're going to get to has to do with the transition of cesium atoms. So let's take a look at the other units. Here is the second. The second is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine lines of the ground state of the cesium-133 atom. And once again, this is a constant. And the ampere, unit of electric current, there's the definition. Constant current which, if maintained in two straight parallel conductors of infinite length, of negligible circular cross-section, and placed with 1 meter apart in a vacuum, would produce between these conductors a force equal to 2 times 10 to the minus 7 newtons per meter of length. The Kelvin. The Kelvin is based on another constant. It's the numerical value of the Boltzmann constant to be equal to exactly 1.380649 times 10 to the minus 23rd joules per Kelvin. Yep, joules per Kelvin. The mole, amount of substance of a system which contains as many elementary entities as there are in 0.012 kilograms of carbon-12. The candela is the luminous intensity in a given direction of a source that emits a monochromatic radiation of a frequency 540 times 10 to the 12 hertz, and that has a radiant intensity in the direction of 1/683rd watt per steradian. Wow, that was a lot. Well, you really don't need to know these definitions unless you plan to be working at NIST. But you should know generally that the unit of length in the SI unit of length is meters, the SI unit of time is seconds, the SI units of thermodynamic temperature is Kelvin, and the SI unit of mass is the kilogram. And these units are somewhat, they're independent in that they are based on constants, but they're somewhat dependent on each other because, for example, the kilogram is based on the Boltzmann constant, and the Boltzmann constant is joules seconds. And the joule has kilograms and meters in there, and also seconds. So to figure out the kilogram, you need the meter and you need the second. They're dependent. So that's why you see all these lines going in different directions, because they're based on other units which are based on constants. Then there are derived quantities. And derived quantities are based on the 7 SI units. Then we multiply those by other things. And these are commonly used, but they're not strictly base units. Examples are, for example, area, of course, is a meter times a meter. Volume is meters cubed. Speed or velocity is meters per second, so on and so forth. So these are all derived quantities. They're not the basic SI units. Here's other ones that deal with a magnetic field, also luminance, and other things. There are some derived quantities that have special names and symbols, such as frequency is per second. When something happens per second, we call that the frequency, or hertz. That's the special symbol that we use. Of course, if you're in atmospheric sciences or you go through science, you know, or you've heard of pascals, which is the SI unit for pressure, because it's based on newtons and also area, meters squared. But there are lots of other types of derived quantities. Here's more examples of derived quantities. Celsius, you see, is there. Celsius is based on the Kelvin scale. And there's more. You should know the SI prefixes because these are used with the base SI units and also the derived units to come up with other types of units. And here are all the the prefixes that are used, and they are pretty interesting. Some I've never seen, never used in my life. Some of you are probably familiar with kilo, like kilogram, or millimeter. You've probably heard of that before. And some of these are used also in computers and also in atmospheric sciences. For example, we use the hectopascal. But I've never heard of a yotto or a zeta or an exa. I guess exabyte. When you start talking computer sciences and storage of data or operations, you hear about petaflops and teraflops and things like that. Gigabytes, you probably heard of that before. And then there are some very, very small units, such as the zepto and the atto and the yocto. I guess the atto boy is 10 to the minus 18th boys. Most of us typically use units from 10 to the 9th down to 10 to the minus 9th. You've heard of nanometers, micrometers, or microns. So those are ones that we commonly use, but the other ones are pretty far out there. And then there are other units that are outside SI norms that are acceptable, that we use every day, and they're pretty important. For example, minutes, hours, days are all based on seconds, and we all know what those are. Also, liters, astronomical units, perhaps. And here's other units that are outside SI, but they are acceptable and they're commonly used, such as nautical miles and knots, which are based, of course, these are derived units based on meters, the length. One that I've never heard of is the R. The R is 1 dam squared. But the bar, units of pressure, of course. I frequent bars very often. Also, there is a barn, which is kind of interesting. The barn is a very small meter squared. So there is a checklist, and I included this in Blackboard if you're taking my Atmospheric Sciences 240 class, on the checklist for how to use SI units. I hope you enjoyed this video.